Right now, as you listen to this, the thousands of neurons firing in your cerebral cortex are using the exact same mathematical formula to process my words as a swarm of honeybees uses to select a new hive out in the wild.
It sounds like science fiction, but it is entirely real.
Yeah, and today we actually have the source code to prove it. Welcome to today's deep dive. We are looking at this incredibly dense, just fascinating document titled Distributed Consensisomorphism.md.
Quite a mouthful.
It really is. But the mission here is to explore this fundamental mystery of complex systems, right? Like, how do you achieve deterministic consensus? Basically, how do you make a single unified decision across a massive decentralized network that is just actively drowning in external noise?
And crucially, doing it without any central controller.
Exactly. Because, I mean, we are so conditioned to assume that coordination requires command.
Yeah.
You know, a hierarchy, a boss, a master node telling the subordinate nodes what to do just to prevent utter chaos.
Right, but centralized control introduces a catastrophic single point of failure, and honestly, it violently collides with the thermodynamic limits of spatial scaling.
Meaning what exactly?
Meaning, once a system expands past a certain volume, a single central hub physically just cannot process the incoming telemetry and issue state commands fast enough. The latency, it overwhelms the architecture.
So the system just collapses under its own computational weight.
Precisely. Decentralized networks don't have a boss, so they have to rely on a mechanism the source material identifies as quorum-gated accumulation. That's how they filter out chaos and achieve a unified state.
And I promise you, by the end of this deep dive, you are going to see the explicit mathematical isomorphism connecting, hyperscale server farms, biological superorganisms, and literally cognitive neuroscience.
All the same math.
Okay, let's unpack this. To see this pattern, the document introduces this framework called systems archaeology.
Right, systems archaeology. We have to essentially strip away all the domain-specific jargon, ignore the computer science terms or the evolutionary biology terms, and just examine the raw, universal variables that govern state transition.
Which the source isolates into this framework it calls the abstract system graph, or the ASG.
Yeah, the ASG. It's essentially a 6-variable blueprint for decentralized choice. And the foundation of this ASG begins with the prime core, which the document denotes as N1.
N1, okay.
This is simply the target coordinate. It's the final synchronized win state the system needs to reach. But since there's no central routing table, the system relies on N2, the catalyst sensors.
And these are the decentralized, localized explorer nodes, right?
Exactly. Their function is to actively sample the environment, accumulate evidence, and then attempt to recruit uncommitted nodes over to their candidate state.
So they operate as this exploratory vanguard.
Yeah.
But those N2 sensors are fighting against the third variable, which is external entropy.
Yes. And we aren't just talking about generic confusion here. We are talking about high-variance background interference.
Channel noise, environmental disruption, literally anything actively degrading the signal fidelity between the nodes.
Right. And overcoming that entropy requires work. It requires energy, which introduces our fourth variable, a strict physical boundary called the resource reservoir.
Because you can't just search forever.
Exactly. Every decentralized system operates under a finite metabolic, spatial, or temporal budget. A system cannot explore candidate states indefinitely. It will exhaust its energy reserves or, the operational window will simply close.
So the exploratory phase is constantly burning through this reservoir. And that forces the network to transition from exploration to a hard committal before those resources hit zero.
Right.
But that raises a really fundamental mechanical question for me. You have thousands of sensors gathering localized data. They're fighting background noise, burning through a finite energy budget. Without a centralized clock, like a master switch, how does the system trigger the final decision?
Well, think about a supercooled liquid transitioning into ice. The water molecules, which are like the sensors, are constantly shifting, agitated by thermal entropy.
But they don't freeze one by one in some messy cascade.
Right. No, they don't. They wait for a precise structural threshold. The document calls this fifth variable the boundary barrier. It's a mathematical quorum gate that operates as a strict high-pass filter.
So it's kind of like trying to pick a restaurant with a massive group of friends. You have the scouts, the friends looking at menus on their phones.
The N2 sensors.
Right. And then you have the noise, which is everyone talking over each other. Plus a time limit, everyone is getting hangry, which is a resource reservoir.
I love that. Hangry as thermodynamic limit.
Hey, it's real. And the boundary barrier prevents people from just splitting up. You need a phase transition.
Hmm.
The moment exactly half the group yells, tacos,
Yeah.
and everyone instantly just heads to the cars.
That is exactly it. And what's fascinating here is how this exact formula, this boundary barrier, acts as a thermodynamic limit for spatial scaling. It fundamentally prevents chaos across all forms of reality.
Because it prevents transient noise spikes from causing a premature committal. Right?
Yes. A localized pocket of N2 sensors might get highly agitated by a false positive. But the boundary barrier ensures that local excitement doesn't crash the whole system. The accumulator value has to violently puncture that mathematical threshold.
And the very millisecond that barrier is breached, you hit the sixth and final variable,
The phase transition.
the consensus lock.
Exactly. The system undergoes a sudden nonlinear bifurcation. It instantly broadcasts a suppression signal to all competing alternatives. It locks the entire decentralized network into a coherent, synchronized execution path.
It's just wild. This six-part mathematical skeleton proves that order doesn't require a dictator. It merely requires a strictly defined boundary barrier.
Yeah.
So let's pull this abstract system graph out of the theoretical realm and actually watch it operate in an environment human engineers explicitly designed. Domain A, silicon runtimes.
Right, let's look at servers. Specifically, the document analyzes the Go native wrapped consensus protocol.
Right, so in a distributed server cluster, the prime core, the N1 win state, is the election of a raft leader node to hold the authoritative state machine.
And the catalyst sensors are the follower nodes. They were processing log replication RPCs, remote procedure calls, and broadcasting localized votes across the network topology.
And the external entropy in a data center is, it's brutal. You've got network latency, dropped TCP packets, hardware degradation, network partitions. It continuously threatens to fragment the cluster's reality.
And the resource reservoir draining in the background here is the heartbeat timeout window. Follower nodes expect a steady pulse from the leader.
And if they don't get it,
If a follower's timer expires before receiving that pulse, it just assumes the leader is dead. So it increments its current term, transitions to a candidate state, and initiates a new N2 exploratory election phase.
well, wait, consider a severe entropy event. Like a router fails and a 5-node cluster physically partitions into 2 isolated segments. Say, a group of 3 servers over here and a group of 2 servers over there.
A classic split.
Right. They lose contact with each other. The heartbeat timeout windows on both sides expire simultaneously. Both sides initiate a new election. Intuitively, wouldn't you expect a catastrophic split-brain scenario?
Where 2 distinct leaders are elected, right?
Yeah, the state machine fractures and the whole database corrupts. Doesn't the system just break down?
No, because the boundary barrier mathematically prevents that corruption. In the Raft protocol, the boundary barrier is the commit index quorum.
And how is that defined?
It is rigidly defined as n divided by 2, rounded down, plus 1. So in a 5-node cluster, 5 divided by 2 is 2.5. Round down, you get 2, plus 1 is 3. The quorum gate is exactly 3.
Oh, wow. So you mathematically cannot synthesize 2 absolute majorities out of a finite integer pool.
Exactly. The partitioned group of 2 servers can broadcast RPC votes to each other until their power supplies literally melt down, but their accumulator will never breach the threshold of 3.
So they are infinitely trapped in the exploratory phase, just filtering out the noise of the partition.
Yes. Meanwhile, the side with 3 servers hits the quorum gate. That threshold breach triggers the phase transition, the election committal.
Because the candidate node hitting the quorum of 3 immediately transitions to the leader state.
And it actively suppresses any split-brain candidates by dominating the network with authoritative heartbeat signals. It forces the cluster into deterministic consensus. The math guarantees a singular, unified reality.
Man, human engineers built Raft to enforce a strict digital clock using synchronized CPU cycles to manage that timeout window. But if you strip away the luxury of a CPU clock and you drop this architecture into a chaotic physical environment,
You find something staggering.
here's where it gets really interesting. We didn't invent this algorithm. Nature perfected it millions of years ago in the wild to solve spatial scaling. Domain B takes us to swarm biology, specifically Apis mellifera.
The honeybee.
Right, when a honeybee colony outgrows its hive, a swarm of roughly 10,000 bees clusters on a tree branch, and they face a monumental distributed computing problem.
They have to locate, evaluate, and agree upon a single optimal nesting cavity. from dozens of potential options scattered across several square miles of forest.
So the prime core, our N1, is the optimal cavity.
Right, one with precise volume, highly defensible entrances, and specific thermal properties.
And the catalyst sensors are the scout bees. They only make up a tiny percentage of the swarm, but they fly out in these radial patterns, identify candidate cavities, and return to the surface of the swarm to execute the waggle dance.
Which is basically their biological RPC protocol.
Exactly. The angle relative to the sun indicates direction, and the duration of the waggle circuit encodes the distance and the quality of the site. They are actively trying to recruit uncommitted bees.
But their exploratory phase is heavily constrained by the resource reservoir. They are operating on a razor-thin metabolic margin, burning through their internalized lipid reserves during every miles-long flight.
Plus, they're restricted by diurnal flight time. They have to reach consensus before ambient temperatures drop and the swarm just freezes to death.
And the external entropy is immense. You've got gusting winds, altering flight vectors, sudden rainstorms, suppressing communication.
Not to mention predatory birds or wasps introducing severe attrition to your scout population.
Right, so you have dozens of competing waggle dances happening simultaneously on the surface of the swarm, all advocating for different trees in different directions.
But without a central processor to tally the waggle circuits, the swarm relies on an entirely physical boundary bit, right? Quorum sensing.
Yes. As recruited bees follow the waggle dance, they fly out to the proposed tree hollow and begin milling around inside the cavity. They are not taking a vote back at the hive.
They're using their literal physical bodies as weights on a mathematical scale. The bees aren't calculating the math, they are the math.
Exactly. The boundary barrier is defined by physical density. The bees inside the candidate cavity are constantly colliding with one another.
And when that collision rate indicates a density of roughly 10 to 15 bees present simultaneously,
the quorum gate is breached. The physical manifestation of the density itself is the accumulator.
and the moment that 10 to 15 bee density is achieved, the phase transition fires, the swarm launch.
Right. The scats recognize the threshold breach, they return to the main cluster, and they fundamentally alter their behavior. They stop the waggle dance and begin executing high-frequency piping signals.
Which are these acoustic and vibrational signals that penetrate the swarm, instantly suppressing all the competing waggle dances for inferior sites.
And triggering a synchronized warming of the thoracic flight muscles across thousands of bees. The entire massive cluster lifts into the air as a single, coherent superorganism and navigates directly to the winning coordinate.
Deterministic consensus achieved through localized physical accumulation. Gated by a strict density threshold, executed before the lipid reservoir collapses.
It is the raft protocol rendered in chitin and lipid molecules.
Yeah, the waggle dance is the RPC log request, and the 10 to 15 B density is the majority commit index. It's just brilliant. And this leads us directly to Domain C, bringing the ASG framework into your own prefrontal cortex.
The swarm of cells currently interpreting these audio frequencies.
Exactly, cognitive neuroscience, specifically drift diffusion decision gating inside the brain.
Right. Whenever a neurological system must select a motor action based on ambiguous or noisy sensory telemetry, say, identifying the trajectory of a rapidly moving object in low, thousands of cortical neurons must integrate the data and reach a unified state.
So our prime core here is the executed motor action, like a saccadic eye movement to track the object.
Yes. And the catalyst sensors in this architecture are the integrator neurons, heavily concentrated in regions like the lateral intraparietal area or the LIP.
Okay, so these LIP neurons are continuously bombarded with feed-forward synaptic spikes from the visual cortex. They're accumulating evidence, but biological synaptic junctions are incredibly messy.
Very messy. The external entropy here is stochastic neural noise. Spontaneous baseline firing rates, fluctuating neurotransmitter concentrations, intersecting cognitive workloads. It creates a massive amount of static.
And the resource reservoir drive in the system is the localized availability of cellular ATP alongside the rigid temporal deadline dictated by the environment.
Right. If the object is a threat, the motor action must fire within milliseconds.
So the LIP integrator neurons are absorbing these noisy synaptic spikes, trying to extract the directional signal from the static. But if the neurons fired a motor command every time they got a transient spike, your eyes would just dart wildly in every direction at random.
Which is why the system requires a boundary barrier. In the cortex, that barrier is the threshold membrane potential. The integrator neurons must physically build up localized electrical charge, fighting against the natural voltage leakage of the cell membrane.
Until they cross a very specific millivolt-defined threshold. That electrical threshold is the quorum gate.
Yes. And once the accumulated voltage of the LIP neuron ensemble punctures that strict limit, you see the phase transition. Basal ganglia disinhibition.
Right, because the basal ganglia generally exert this constant, heavy inhibitory brake on your motor pathways,
Right.
using GABAergic signaling to suppress movement.
But the moment the LIP voltage threshold is breached, it triggers a sudden cascading release of that GABAergic inhibition.
The dam bursts. The localized motor gate pops open. The saccade fires instantly with absolute synchronization, and collateral neural pathways simultaneously suppress all alternative motor plans. The decision is locked. Okay, but encountering this drift diffusion model, it often provokes a deep existential crisis regarding determinism. So when I think I'm making a conscious choice to look left or right, I'm not really choosing. My LIP neurons are just playing a microscopic game of tug-of-war until one side randomly hits a high-score voltage threshold.
If we connect this to the bigger picture, it actually forces us to reframe intent entirely. The quorum gate is not negating purpose. It is the physical architecture of purpose.
How so?
Because in a universe governed by high-variance entropy, intent cannot exist without a mathematical filter. Without that strict membrane voltage threshold acting as a high-pass filter, your actions would be dictated solely by stochastic thermal noise. You'd just twitch randomly.
Right.
The ASG framework is the beautiful thermodynamic mechanism by which an organism actually exerts its will against the chaos of the environment.
Oh, wow. Okay, so systems archaeology shows us that whether you are coding Go binaries, tracking a bee swarm, or observing a saccadic eye movement, the math is identical. So what does this all mean? How do we actually weaponize this biological isomorphism today?
The source document details an incredible application for this. An AI code builder that utilizes the ASG to write ultra-efficient software architectures.
Okay.
Standard enterprise backend development historically struggles with concurrency. Managing thousands of parallel processes attempting to mutate the same data pool. The traditional human approach is defensive. We use complex database mutex locks, mutual exclusion objects.
Right. Using old mutex locks is like forcing a company of thousands to share a single talking stick. Only one person can speak at a time. It's essentially forcing a multi-lane, high-speed superhighway to merge into a single toll booth.
Exactly. When one thread needs to access the database, the mutex drops the gate. Every other car on the highway has to slam on the brakes and idle.
They burn fuel, representing severe CPU thrashing and lock contention, while they wait for the gate to lift.
It's a rigid blocking architecture that artificially chokes the system's spatial scaling. But the AI code builder discards the toll booth entirely. It implements the biological drift diffusion model in Go.
So instead of blocking access, it deploys thousands of ultra-lightweight stateless worker goroutines, the Scout Swarm.
Right. And as they gather telemetry, they don't wait in line. They asynchronously write their evidence packets into an unbuffered, in-memory fan-in channel. The data flows like fluid traffic entering a massive multi-lane roundabout.
There are no locks, no gate.
Gone. The magic happens at the center of the roundabout with the drift diffusion integrator. The architecture utilizes a single dedicated collector goroutine running a high-speed select loop. It acts exactly like the LIP integrator neuron in the cerebral cortex.
It just sits there reading the incoming channel, silently tallying the density of the traffic. This new biological approach is like a highly efficient crowd meter that listens to the hum of the room.
And crucially, the collector applies a mathematical decay constant, denoted by the Greek letter gamma. This decay constant is the programmatic equivalent of the biological membrane voltage leakage, or the natural energetic degradation of a honeybee's waggle dance over time.
I see. So as the collector increments an in-memory counter based on incoming signals, the gamma constant continuously bleeds off a fraction of that value over time.
Yes, that is absolute mechanical sympathy. By bleeding off the value, the collector naturally filters out transient noise spikes. A sudden random burst of isolated signals will decay before hitting the threshold.
But a sustained high-fidelity signal will accumulate faster than the gamma decay can bleed it off, right? So it steadily drives the counter upward.
Exactly, and because the architecture relies on a non-blocking quorum gate, the collector goroutine evaluates that counter against the threshold utilizing a single CPU register instruction.
So the evaluation is computationally weightless.
Completely weightless. The exact millisecond the volume outpaces the decay and hits the sweet spot, the register trips. The collector immediately closes the input channel, suppressing all further N2 exploration, and broadcasts the state change across the application.
instantly triggering an action, with zero heat memory allocations and zero blocking. It works with the fluid dynamics of the system rather than fighting against them with rigid toll booths.
It achieves perfect deterministic consensus under heavy concurrency load.
It's just incredible. We have taken a single conceptual blueprint, this quorum-gated accumulation, and watched it seamlessly govern the routing of an IP packet, the survival and relocation of an insect colony, and the very stark of human decision-making.
It radically alters how you analyze complex systems. I mean, the next time you make a split-second physical maneuver or you observe a massive synchronized network operating flawlessly under pressure, you should remember the invisible mathematics happening beneath the surface.
The abstract system graph.
Exactly. You are watching localized accumulation racing against a metabolic clock, pushing relentlessly against a silent threshold, just waiting for the instant of phase transition.
It really leaves you with a staggering implication. If biological evolution over millions of years and human computer science over mere decades both inevitably converged on the exact same mathematical formula for extracting order from chaos, what does that say about the fundamental nature of the universe?
That's the real question, isn't it?
Right. If we eventually encounter an alien intelligence operating on an entirely different biochemical foundation, or if we finally compile a true artificial general intelligence, will we peel back their cognitive architectures only to find this exact same quorum gate waiting for us at the core of their minds too?
Well, if the thermodynamic limits of spatial scaling are universal, then the mathematical solutions to those limits must be universal as well.
An invisible law of nature, hiding in plain sight. Thank you for joining us on this deep dive. Until next time.